Good morning, everyone. This is Amit Kumar Singh, and welcome to the new chapter on operation research. Today, in this class, we'll deal with assignment problem. We have done transportation problem. In the transportation problem, when we worked on transportation problem was the special case of linear programming problem, where we used to work on how we can deliver X unit of raw material to X unit of places. So those scenarios we have done in transportation problem. Transportation problem was all about delivering certain goods to certain parts depending upon the requirement on that parts. So that was basically a transportation problem. In the case of transportation problem, we used to get a rectangular matrix, and we had to make sure that in the transportation problem the objective function should be minimization and the total demand should be equal to total supply. Now in today class, what we'll deal with assignment problem. Assignment problem is the special case of transportation problem, where in the case of assignment problem, we'll talk about assigning job. So like suppose there are 5 jobs. Suppose here, for a given scenario, you have 5 jobs. Suppose those 5 jobs are 1, 2, 3, 4, 5. So you have 5 jobs, and you have 5 mechanics who can do these 5 jobs. So A, B, C, D. These are the name of mechanic who can do this job. These are the name of mechanics who can do this job. So we're talking about assigning jobs. So these jobs can be done by 5 mechanics. So suppose there are 5 mechanics who can do these jobs. You're talking about 5 mechanics. Now, whenever the job is being done by these 5 mechanics, they will take some cost. So whenever anything happens, you need to pay money for that. So in order that there are 5 mechanics and there are 5 jobs are there, so the cost involved in doing that, suppose if I give you, suppose this is 10, then it is 9, then it is 7, then it is 3, then it is 9. Let me write down the data. So it is 3, 7, 5, 5, 10. Then you have 3, 8, 6, 8, 9. Then you have 2, 2, 2, 2, 6. And similarly for the job 5, the cost involved is 8, 7, 4, 4, and 10. So there are 5 mechanics are there, and there are 5 jobs are there. So you can see this is called assignment problem. So this, what you can see, this is called assignment problem. So if for this problem, if you notice, there are 5 jobs are there, and there are 5 mechanics are there who can do this job, and the cost associated for these jobs to be done by these 5 mechanics is given to you. Now the question arises, which mechanic will do which job? Now when we work on assignment problem, the few things we need to keep in your mind, that one mechanic is to assign one job only, or one job is to be assigned to one mechanic. So no person can do more than one job, and no job is done by more than one person. So in the assignment problem, the word, if you understand here, the word itself is talking about the meaning. In the case of assignment problem, you talk about assigning work to people. You are talking about assigning work to the people. So how you assign work to the people? You have to assign work to the people in such a way that every person get one job, and every job is to be done by one person, and that you have to do. Now the same way, if you remember the way we used to do transportation problem, is the same way you can do assignment problem. So here also, any person, I can assign randomly any job to any person, and then I can calculate the total cost associated with assigning the job. That is the way you can do, like the way you can like the same way how you used to do transportation problem. So here any mechanic can do any job. You can play that kind of game. Like suppose you can play that game that suppose mechanic A do job 1, mechanic do job 2, mechanic 3 job 3, mechanic 4 will do job 4, 5, and mechanic 5 will do job 4. You can assign randomly any job to any person, that doesn't matter. But that way you will not get the optimal data. So ultimately, I hope you are understanding that when the 5 jobs are there and 5 mechanics are there, and you have to assign one job to one mechanic, so definitely you will try to do in such a way that the total cost should be minimized. Again, in the case of assignment problem, again when you deal with assignment problem, so the objective function when we are dealing with assignment problem, again it is assignment problem is nothing but it's application of transportation problem. So in the case of assignment problem, your objective function should be minimization. Your objective function should be minimization. In case if the data is given about maximization, then we'll convert the maximal data into minimal data by subtracting the highest element in the matrix. Whatever is the highest element, from that we'll subtract all the elements, like the way how we done in the transportation problem, like the same way you do in assignment problem. Only thing that in sometime in exam and all, they'll ask you the difference between assignment problem and transportation problem. Only thing you have to remember that if for the assignment problem, you have to remember that for the assignment problem, whenever you work on assignment problem, so for the assignment problem, the matrix should be square matrix. The matrix, what you see, the matrix should be a square matrix. So for the assignment problem, the matrix what you can see, it should be square matrix. In case if that is not a square matrix, so we'll make it square matrix by adding dummy row or dummy column. So if when we are working about transportation problem, it doesn't matter our matrix is square or rectangular. So it doesn't matter. I believe everyone understand the property of a square, that every square is a rectangle only, but every rectangle is not a square. So those rectangles are square for which the length is equal to breadth. Okay. So when we work on assignment problem, if the matrix is a square, if your matrix is not a square, then you cannot work on assignment problem. So that is the first and foremost thing you have to keep that in your mind. And then the objective function should be minimization. Now, whenever you are working on assignment problem, so the method what we will use to solve the assignment problem, whenever you get assignment problem, so I'll tell you technique of solving the assignment problem. So that method what we follow, that is called as Hungarian approach. You can remember this name. So the method what we follow to solve the assignment problem, that is called as Hungarian approach. So by using Hungarian approach, we can solve any assignment problem given to us. So the method what we follow whenever we get the assignment problem, so the method what we follow to solve the given problem is called as Hungarian approach. So keep that in your mind. It's very simple. Now, what we do to solve the problem whenever we get the assignment problem. So how we solve that problem. So whenever we get the assignment problem, so what is this Hungarian approach is all about? So if you understand, you have to figure out a method. You have to figure out your method. That method, what you have to figure out, you have to figure out that method in such a way. You have to make sure that you assign one job to one person. You have to assign one job to one person, and you have to assign in such a way that the total cost should be minimized. That is your agenda. The agenda of working on assignment problem is to make sure one person get one job, or one job is to given to one person, and that to be done in such a way that overall your cost should be minimized. So what is the approach to solve the assignment problem? So approach to solve the assignment problem is called as Hungarian approach. So we apply Hungarian approach to solve the assignment problem. So whenever we get the assignment problem, what we basically do, the first step is to identify the first step to identify the first step what you need to do to solve the assignment problem is to identify the row minima. Identify the row minima in every row. Identify the row minima in every row. So in every row, you have to identify the element which is the smallest element. So if for every row, you have to find the element which is the smallest element. So you can see every row, and I'm looking for the element which is the smallest element. So for every row, find the smallest element. So one by one, you can look into every row and find the smallest element. So for every row, you have to identify the row minima. For every row, you have to identify the row minima. Okay, I've done that. Then what is the next step? Next step is that subtract, subtract row minima, subtract your row minima, subtract your row minima to subtract your row minima from every element. So subtract your row minima from every element, from every element, from each element in every row, in each element in every row. So what you have to do, the approach, the Hungarian approach, what we follow, for that what we do, we identify the row minima in every row. So every row identify the row minima. Then I'll subtract all the element of this row by this row minima. So if I subtract all the element of this row by this row minima, so if I do that, so if I do that, so this would be 8, then 1, so 10 minus 2, 3 minus 2, 3 minus 2, 2 minus 2, 8 minus 2. So like this I'll do. So again for the second row, the minimum element is 2. So 9 minus 2, 7 minus 2, 8 minus 2, 2 minus 2, 7 minus 2. Then similarly the third one is 7 minus 2, then 5 minus 2, then 6 minus 2, 2 minus 2, 4 minus 2, then 3 minus 2, then 5 minus 2, then 8 minus 2, 2 minus 2, 2, 4 minus 2, then 9 minus 6, then 10 minus 6, then 9 minus 6, then 6 minus 6, and then 10 minus 6. So I have to identify the minimum element in each row, and that minimum element I have to subtract from every element in the row. So that I have to do. So that work you have to do. So once you're done with that work, then the third work what you have to do is to identify the minimal element. You have to identify the minimum element in every column. So you have to identify the minimal element in every column. So that is the third step you have to do. So the third step of Hungarian approach, like identify the smallest element in every column. So first you identified the smallest element in every row, then you subtracted all the element of the row by that smallest element. Then once you're done with that work, in the third step you have to identify the smallest element in every column. So you have to identify the smallest element in every column. You have to identify the smallest element in every column. You have to identify the smallest element in every column. Once you identify the smallest element in every column, then what is the fourth step? The fourth step is that subtract all the elements, subtract all the element of the column, subtract all the element of the column from the smallest element, from the smallest element, from the smallest element. So the fourth step you have to do is that to subtract all the element of the column from the smallest element. So the third step was that you identify the minimum element in every column. The fourth step is that once you identify the smallest element in every column, then subtract all the element of the column by that smallest element. Okay, so like the same way you did row wise, now you have to do column wise. Now the same work you have to do column wise. Now same work you have to do column wise. Same work you have to do column wise. So if you do column wise, so this would be 8 minus 1 7, 7 minus 1 6, 5 minus 1 4, 1 minus 1 0, 3 minus 1 2. Then 1 minus 1 0, 5 minus 1 4, then 3 minus 1 2, 3 minus 1 2, 4 minus 1 3. Then 1 minus 1 0, 6 minus 1 5, 4 minus 1 3, then 6 minus 1 5, 3 minus 1 2, then this is 0 0 0 0 0. Then here 6 minus 2 4, 5 minus 2 3, 2 minus 2 0 0, and 4 minus 2 2. So you have to do this work. So you have done row wise, column wise. So what is this Hungarian approach is all about? So in the Hungarian approach, you identified the smallest element of every row, and whatever the smallest element you identified in every row, subtract all the element of the row from the smallest element. Then you identified the smallest element in every column. Then subtract all the element of the column from the smallest element. So that work you have to do row wise first, then you have to do column wise. Very simple. So once you're done with that, you will get like this. You will get a rectangle or you get a square which have zeros. So ultimately, you have to understand that you have to understand one thing, that ultimately what we are trying to do, we are trying to create zero in every row and column. We are trying to create zero, and ultimately our work will be assigned based on zero. So if you are noticing, I identified the small element in every row, then I subtracted all the element of the row from the smallest element, then I identified the smallest element in every column, then I subtracted all the element of the column by smallest element. So ultimately, if you can use your basic common sense, you can easily understand that what we are trying to develop, we are trying to develop zeros in rows and columns, and then we'll do the assignment of job in every row and column. And for doing the assignment of job in every row and column, we'll work on zeros. We'll see where zeros are there in every row and column. Except zero, all other elements are not so significant for us. So we'll work on assignment of work in every rows and column, and that assignment of what we'll do in every row and column, that depends upon the zeros in every row and column. Okay, that work we'll do. Anyone have any doubt till now? Anyone have any doubt? Please write in the chat box if anyone want to ask anything. Before I proceed, anyone have any doubt? Please write in the chat box. Before I proceed, anyone have any doubt? Please ask me. So it is very easy. It comes every time for your exam. 5 marks question, it will come for you. It will not come for 10 marks and all. So it is not at all lengthy. So your examiner cannot ask you in 10 marks, because it is not like that it can be asked in 10 marks, but they ask in 5 marks. So it is very easy, and it's very important for exam point of view. Easy and important. So by that you can understand the relevance of this topic. So now now ultimately you identified the minimum element in every row. You subtracted all the element of row with that minimum element. Then you identified the minimum element in every column. You subtracted all the element of the column from the minimum element. So ultimately you got a matrix, some elements and zero. Okay. So ultimately the work is to play around zero. Now ultimately your work is to play around zero. So now you work and around zero for the assignment. So for assignment, when we work on assignment, so when we work on assignment, so ultimately now when you are working on assignment, what you'll do, so what you do, you have to do assignment, you have to assign you have to assign 0, you have to assign 0 from every row, you have to assign 0 from every row if the row contain only 1 0, if the row contain only 1 0. So first what you will do when you do assignment, when you give assignment to every row, so that assignment what you're giving to every row, you have to give in such a way, you have to give preference to that row which has only 1 0. Now if you see the row 1, if you see this row 1, so if you see the first row has 3 0. So don't do assignment now. Okay, ignore it. If you see second row, it has only 1 0. Okay, it has only 1 0. So when you are assigning work to the row and column, you have to assign in such a way that you have to give preference to that row which has only 1 0. If it is 1 0, you guys, you have to understand that we are assigning work. We are assigning work, and when we are assigning work, we are assigning work based on zeros. So when we are assigning work to the based on 0, and if one row has more than 1 0, then it is creating confusion that which row 0 can I prefer. So what you have to understand, those rows which has more than 1 0, just ignore them. So row 2 has 1 0, row 3 has 2 zeros, row 3 has 3 row 3 has 2 0, so row 3 has 2 0, row 4, fourth row has 3 0, then row 5, fifth row has 1 0. So what you will do when you are assigning row wise, first we will do assigning row wise, then we'll do assigning column wise. So when you are assigning row wise, give preference to that row which has only 1 0. Any row which has more than 1 0, just ignore them. Any row which has more than 1 0, you can ignore them for the time being. For the time being, just ignore that row which has more than 1 0. So the second row has 1 0. Now the second row has 1 0. It means that the mechanic 2, if you remember, 5 mechanics were there, A, B, C, D, E. 5 mechanics were there. It means mechanic B got the job 4. Job were 1, 2, 3, 4, 5. It means mechanic B got the job 5. So because row B, if the row 2 has only 1 0, so you will assign the work to that 0. So if you assign this work to that 0, so this is job 1, job 2, this is job 3, this is job 4, this is job 5. So it means you have assigned the job 4 to mechanic B, because the second row has only 1 0. So when you do the assignment row wise, you will give preference to that row which has only 1 0. Similarly, if you see the fifth row, fifth row again have 1 0. So again the fifth row has again 1 0, and that is of fourth one. So it means that now you have mechanic D and you have mechanic E, and both they can get job 4. So when we do this assignment, we do assignment row wise. So which row came first, row B or row E? Row B came now. Now if you assign a work to row B, now this work not be identified. Now this work cannot be given to anyone else. So you do row wise, and when you do this row wise, then see the column and the row of that assignment. If any zeros are there, just cancel that 0, because one person can do only one job, and one job can be given to only one person. Now cancel like this. So you have done row wise. Now you have done the work row wise. 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 Similarly, you have to do the work column wise. Now if you see the column, column 1 has only 1 0. Column 1 has 1 0. If you see column 2, it has again 1 0. Column 3 has again 1 0. Column 4 to done. Column 5 has 2 0. So what you will do now, now we have done row wise. Now the same work we'll do column wise. So when we do the same work column wise, we'll give preference to that column which has 1 0. Okay, so any column which has more than 1 0, you don't do assignment to that row. Now column 1 has 1 0, so you assign the work to that 0. Now cancel any 0 if that is there. Now cancel any 0 if you can see that 0 in the corresponding row and column. Now if you see column 2 has only 1 0, so assign the work to that row and cancel any 0 in that row and column. Now column 3 nothing can be done, column 4 nothing can be done, column 5 has 2 0, now 1 cancelled and 1 0, so don't touch it. So first when you do assignment to row wise and then column wise, and when you do assignment row wise and column wise, do assignment if it contains only 1 0. So one by one we'll do. So first time when you do assignment, you have done assignment you have done assignment to every row and column wise if it has only 1 0. So similar approach is worked on column wise, is worked for column wise, is worked for column wise. So first you saw row wise, and you did assignment to that row which has only 1 0. Similarly, you saw column wise and you did assignment to that column which had only 1 0. So first we saw row wise and we did assignment to that row which has only 1 0. Then we saw column wise and we did assignment to that column has 1 0. So like this you have to do row wise and column wise. Like row wise and column wise you have to do assignment. Like row wise and column wise you have to do assignment. So you have to see every row, you have to see row wise, you have to see row wise, you have to see row wise. Which row has 1 0, do assignment. Okay, any row which has more than 1 0, don't touch it. Then you see column wise, do assignment to that column which has 1 0. Any column which has more than 1 0, don't touch it. So now you saw row wise, then you saw column wise, and you did assignment to that row and that column which has 1 0. Now again you will see row wise. Again, just follow the same step. Follow the same steps. Now you have to follow the same steps. Now what you'll do? Now we'll observe those rows. Now you'll observe those rows which has 2 zeros, that has 2 zeros, one cancelled, and one available, So you have to understand you are playing a game. First what you did, you saw those rows which has only 1 0. Okay, then you'll see those rows which has 2 zeros, one is cancelled and one is there. So if you see row 1, nothing's there, row 2, nothing's there, row 3, if you see, it has 2 zeros, one cancelled and one is there. So now you'll do assignment to that. Okay, so row 4, nothing is there, row 5, nothing is there, then column 1, column 2, now nothing is there. So what you have done, guys, so I repeat this step. So first what you have to do, you have to, once you get the problem, this is the problem. Now once you get the problem, you have to assign work to every mechanic, and every mechanic is assigned a job. So when every mechanic is assigned a job, when every job is assigned to a mechanic, you have to do in such a way that one person get only one job. You have to do in such a way that one person get one job, and you have to find the optimal value. Randomly you cannot do anything. So you have to do optimally. So when you are playing this game optimally, so how you can play this game optimally, what you have to do, you have to identify the smallest element in every row. You have to identify the smallest element in every row. You have to subtract all the element of the row from the smallest element. Once you've done this work row wise, then you have to do the same job column wise. So you have to identify the smallest element in every column, and you have to subtract all the element of the column from the smallest element. So you have to do this work row wise, then you have to do this work column wise. So you have to identify the smallest element in every row, subtract all the smallest element of every row, uh, subtract all the element of the row from the smallest element. Then you do this work column wise. You identify the smallest element in every column. Then you subtract all the element of the column from the smallest element. So once you're done with that work, ultimately you will get a matrix. That matrix which will have certain zeros, row wise and column wise. So now you have to understand the game, this Hungarian approach, the method what I'm talking about here. In this method, you will assign work. In this method, you will assign work in every row and column wise. You assign work to every row and column wise. When you are assigning work to every row and column wise, you have to assign work in such a way that you have to give preference to that row and that column which has only one zero. So first give preference to that row and that column which has only one zero. Now between row and column we'll give preference to row. So first we'll look row wise, then we'll look column wise. So first we look row wise, then we look when they see column wise. So see row wise, and don't touch those rows which has more than one zero. Do not touch those rows which has more than one zero. If any row has one zero, then do assignment to that row. And when you did assignment to that row, then cancel all the zeros in the corresponding row and column wise. Okay, once you've done that work, observe the data row wise. Once you observe the data row wise, now observe the data column wise. Now observe the data column wise. Once you're done with that, so first you saw those rows. First you saw those rows which has one zero. First you saw those rows. First you saw those rows which has one zero. Then you will see. First you saw those rows which has one zeros. First we'll see those rows which has one zero. Then we'll see those columns which has one zero. Then we'll see those rows which has two zeros, one cancelled, one available. Then we'll see column wise those columns which has two zero, one cancelled, one available. Then we'll see those rows which has two zeros. Then we'll see those columns which has two zeros. Then we'll see those rows has three zeros, one cancelled and one available or two available, like this. So one by one, preference wise, you will do assignment. Simple. You just need to play the game. Now, if you observe, this is the final output what I get. Now, if you observe in this outcome what I'm getting, in this outcome, the mechanic one, in this outcome, the mechanic one got the work, mechanic 2 got the work, mechanic 3 got the work, mechanic 4 got the work, but mechanic 5 did not get the job because for the mechanic 5 there is no geo available to be assigned. Now means it is injustice. If you observe, the mechanic A, B, C, D, they got a job, but mechanic 5 did not get the job. It means this is injustice. Means it is not the optimal solution. It means it is not the optimal. Means it is not the optimal allocation. So you have to do optimal allocation. It is not now what we are getting. That is not the optimal allocation. Why it is not the optimal allocation? That would be the optimal allocation. What that would be the optimal allocation where every mechanic get one job and every job is got by one mechanic. Then that allocation would be optimal allocation. Now the allocation what you're seeing is not the optimal allocation. So you have to make it optimal allocation. So for that we'll play a game. Remember, for the optimal solution in transportation problem, we followed that game of UV method. Same way game, similar like that game will follow here. Now for that, let me write down this problem once time. Anyone having doubt, please ask me. Before that, let me write it down. Let me write it down. Anyone want to ask anything? Okay, I'm writing in a notebook. Anyone want to ask anything? They can ask. Okay. So because for that I need to go down. So I'm writing. This is not the optimal allocation. So how will we do the optimal allocation? So now this is not the optimal allocation. So the solution you got is 7 0 0, then 0, then 4, then 6 4 5 0 3, then it was 4 2 3 0 0, then it was 0 2 5 0 0. So this is 2 3 2 0 2. Okay. So if you observe the same thing I'm writing here, the same thing I've written here. Okay. I hope so. This is not the optimal allocation. So the same thing I've written here. So how we allocated? So first, second row we had done allocation. Second row we had done allocation. So we cancelled all the zeros of this row and column. Okay. Then here we have done allocation here. Okay. Then here we did allocation here. So we cancelled here. Similarly, for second column we did allocation here. So we cancelled this. So this is ultimate. This is the output what we got, which I'm claiming that is not the optimal allocation. This is the output what we got, so which I'm claiming that this is not the optimal allocation. So why it is not the optimal allocation? Why it is not the optimal allocation? So that allocation is optimal. Why it is not the optimal allocation? That because every row and every column is not being occupied. So if you observe the row 1, row 2, row 3, row 4 has got allocation, but row 5 did not get allocation. That shows that this is not the optimal allocation. So what we have to do, we have to make sure that the allocation should be optimal. So we have to make sure that the allocation should be optimal. So for making the optimal allocation, this is not the optimal allocation. So for making the optimal allocation, what you have to do, you have to tick that row which is not allocated. So for doing the optimal allocation, what you have to do, you have to tick that row which is not allocated. Okay. So have you done that ticking? So tick that row for optimal allocation. What you have to do? So for optimal allocation, for optimal allocation, what you have to do? For optimal allocation, what you have to do? What you have to do? So tick that row. The first step, tick the row, tick the row, tick the row which is not allocated. So tick the row which is not allocated. Tick the row which is not allocated. Okay. Then that see in that row if there is any zero. So tick the corresponding column for the row which is where zero is there. So once you tick the row, then what you have to do? You have to tick the corresponding column. So what you have to do? Tick the corresponding column. Tick the corresponding column. Tick the corresponding column of any element of the row of the same row. Tick the corresponding column of any element of the same row where zero is there. Where zero is there. I've done that. What is the third step? What is the third step? Okay. Now what is the third step? What is the third step? In the third step, what you will do? In the third step, what you will do? Then check the column which is ticked. then check the column which is ticked, then check the column which is ticked, then check the column which is ticked and tick, and then tick the row, and then tick the row where where allocation is there, where allocation is there in the column, the same column. So in the same column. So what you have to do in the third step, the first step what you had done, in the first step what you did, in the first step what you did, so in the first step what you did, again I'm repeating the steps. In the first step what you have to do, you have to see that row which is not allocated. So which row is not allocated? Row 1 is allocated, row 2 is allocated, row 3 is allocated, row 4 is allocated, row 5 is not allocated. So tick that row which is not allocated. Now tick that row which is not allocated. So I have ticked that row. Which is that row which is not allocated? Row 5. Yes sir, I've done that sir. Okay sir, then what can I do? Then see in that row. What is that row? That row is 5. Now see in that row, see if any zeros are there. Whatever zeros are there, tick that zeros. So whatever the zeros are there, tick the corresponding column for those zeros. Yes sir, there's only one zero sir. Row 5 was not allocated. So I tick the row 5. Now inside the row 5, there's only one zero. So I tick the corresponding column for that zero. I've done that. Okay. Now have you done that? Yes sir, I've done that. Okay. Now what you do? Now what to do? Now you see this column. Now see the column for that row. What is the, see the column for that row. Now once you tick that column, now see the column for that row. See if there's allocation is there. Is there any allocation is there in that column? Yes sir. Where is that allocation? Is there any allocation is there in this column? Yes sir. Where is that allocation? Sir, here is this allocation. Okay. So what you do, tick the row for that allocation. So which row the allocation is done? So that allocation is done for row 2. So tick that corresponding row for that. Is that done? Yes sir. Is all ticking done? Yes sir. This is the way how you need to do. So all ticking done? Yes sir. All ticking done. Okay. So once you're sure that all your ticking is done, once you're sure that all your ticking is done, once you're sure that all your ticking is done, now what you have to do in step 4, now what you have to do, cross all the ticked column, cross all the ticked column and unticked row, and unticked row, unticked row. So what you have to do in the fourth step, what you have to do in the fourth step, in the fourth step, what you have to do in the fourth step. So in the fourth step, what you have to do, now certain rows and certain columns are ticked. So what you do, draw a cross. So draw cross to those columns which is ticked and those rows which is not ticked. So draw a line over, now draw a line over those rows which are not ticked and draw a line over those columns which are ticked. So you have to play this game. So once your ticking part is done, you have to draw a line. You have to draw a line to those rows which are not ticked and those columns which are ticked. So we knew that the allocation was not optimal because row 1, row 2, row 3, row 4 were allocated, but row 5 was not allocated. So in order to play the game of optimality in the assignment problem, what we did, these are the steps what we followed for the optimal allocation. So we tick that row which is not allocated. Now inside that row we saw where zeros is there, so we tick that column for the corresponding zero. Then we went inside the column, we see where allocation is there, then we tick that allocation, then we draw a line over ticked column and unticked row. So then we draw a line over ticked column and unticked row. So it means we have drawn line. So draw line. We have drawn line over. We have drawn line over. We have draw line over ticked ticked column, and unticked row. So ticked column and unticked row. We have done there. So is this part done? Yes, sir. This part is done. Is this part done? Yes, sir. That part is done. So is that part done? Yes, sir. That part is done. Okay. Okay. Now what you do? Now what you'll do? Now what you'll do? Now what you'll do? Now what is your fifth step? Your fifth step is, what is your fifth step? What is your fifth step? So what is your fifth step? So your fifth step is to observe all the elements, observe all the element which is not ticked, which is not crossed. Observe all the element which is not crossed. Now observe all the element which is not crossed. Identify the smallest element. Identify the smallest element. Identify the smallest element which is not crossed. Identify the smallest element which is not crossed. Now identify the smallest element which is not crossed. Call that element as theta. Now what you have to do, see the element which is not crossed. Here see the element which is not crossed. So which are the elements which are not crossed? This is not crossed. This is not crossed. This is not crossed. This is not crossed. Then this is not crossed. Then this is not crossed. This is not crossed. This is not crossed. So see the element which are not crossed. So now see the elements which are not crossed. Okay, okay, I am seeing those elements which are not crossed. So out of all the elements which is not crossed, identify the smallest element. Out of all the elements which are not crossed, identify the smallest element. That smallest element we call as a theta. So which is the smallest element, guys? Identify the smallest element. So what is your smallest element? So what is the smallest element which is not crossed? Identify the smallest element here. What is that smallest element which is not crossed? So identify the smallest element which is not crossed. So out of all the element, what is the smallest element? The smallest element is theta. So that theta here, if you can observe, 6, 4, 5, 3, 2, 2, 3, 2, 2. So which is the smallest element? The smallest element is 2. The smallest element is 2. So theta is equal to 2. So the smallest element is 2. So theta is equal to 2. Okay. So that smallest element, we call that smallest element as theta. Now what you have to do? Now what you have to do? Subtract all the elements. Subtract all the elements which are not crossed. 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 Subtract all the elements which are not crossed by theta. Subtract all the elements which are not crossed by theta. Now what you have to do? You have to subtract all the elements which are not crossed by theta. So subtract all these elements. So all these elements which are not crossed. So what is your theta? What is your theta? The theta for you is 2. Smallest element is the theta. So what is the theta? Theta is the smallest element of all the element which is not crossed. So that is the theta. So theta is equal to 2. So subtract all the element. Now subtract all the element which are not crossed by theta. So 6 minus 2, 4, 4 minus 2, 2, 5 minus 2, 3, 5 minus 2, 3, then 3 minus 2, 1, like that. So subtract all the elements which are not crossed by theta. Okay. Now, while doing that, do not touch, do not touch, do not touch those elements, do not touch those elements which is crossed. When you are subtracting, do not touch those elements which are crossed. So any element which are crossed, do not touch those elements. So they have blessing of God. So all the elements which are crossed, so they have the blessing of God. So do not touch those elements. Okay. do not touch those elements, keep them like that. So this will be like this. So if you see this, so this will be like this. So any element which is crossed, like 7, so 7 will remain 7 because it crossed. Then 0 will remain 0, 0 will remain 0, 6 will become 6 minus 2, 4, 4 minus 2, 2, 5 minus 2, 3. So those elements which are crossed, do not touch them. 4, so 4 will remain 4, 2 will remain 2, 3 will remain 3 because they are crossed. So when any element which are crossed, do not touch them. You only subtract those elements which are which are which are not crossed. Only you will subtract those elements. Those elements which are crossed, do not touch them. Keep them like that. Okay. So any element, any element which is bisected, any element which is bisected, any element which is bisected, bisection like this. So any element which is bisected like this, what you do, add theta to those elements. Add theta to those elements. So any element which is bisected, so what you do, add theta to those elements. So this thing you have to remember. So these things you have to remember. So this thing you have to remember, that you don't have to touch, that you don't have to touch, that you don't have to touch those elements. You don't have to touch those elements which is being crossed by the line. So any line, so if above any element, if line is gone, do not touch that element. Okay, those elements which are free, which does not have any line, which does not have any line over them, you subtract those elements from theta. And any line with any element over which two lines gone, so you add theta to them. Okay, so you can see 7, 0, 0. Then you can see over the 0, two lines gone. So you add theta. So 0 plus 2, it becomes 2. And then 4, one line gone, so do not touch it. Over 0, one line gone, so do not touch it. Then 3 is without any line, so 3 minus 2, 1. Now if you see the third 0, two line gone, so add 2, and then it remain not touched. Then 0, one line gone, so do not touch it. Then 2, then 5, then 2 line gone, so 2, then 0, then this 2, 2 minus 2, 0, 3 minus 2, 1, 2 minus 2, 0, one line gone over, so one line gone over, do not touch it, two line gone over, add it, and this will become 0. Now this is the new set of element you will got. Now this is the new set of element you will got. So now on this we'll play the game. So the same game of 0 and all what we have played, now we'll do on this. Now we'll try to put allocation. Now we'll try to put allocation on this set of elements. Again, if you are trying to put allocation on this set of element, now again you will do allocation to that row which has only 1 0. Then we will do allocation to that column which has 1 0. Then we'll do allocation to that row which has 1 0 cancelled and 1 row available, like that. One by one we'll play the game. Okay, we'll give preference for the allocation. So the preference of allocation, what we'll do, we'll give preference first to that row which has only 1 0. So if you see row 2, it has 1 0. So we'll do allocation for that. If you see row 2, it has 1 0. So we have done allocation for that. Row 3 has again 1 0. So I have done allocation for that. Row 3 again 1 0. Row 4 has 2 zeros, so do not touch it. Row 5 has more than 2 zeros, do not touch it. Column 1 has 2 0, do not touch it. Column 2 has 1 0, so do allocation. Column 2 has 1 0, do allocation. Column 3 has 2 0, 1 cancelled, 1 available, do not touch it. Column 4, you can't do anything. Column 5, you cannot do anything. Now we saw row wise. First we saw row wise and we did allocation to that row which has only 1 0. So we have done that well. Now we saw column wise. We have to do allocation to that column which has 1 0. So we have done that. Now we see row wise. Now we are going to see row wise and we'll do allocation to that row which has 2 0. one cross one available. So if you see row 4, if you see row 4, it has 2 0, one cross one available. So I'll do allocation here. Okay. Now row 5, nothing can be done. Okay. Now you see column wise. Now you see column wise. Give preference to that column which has 2 0, one cross one available. Column 1 done. Column 2 cannot do anything. Column 3 has 2 0, one cross one available. Okay. Now I think we are done with. Now if you see, now we got the optimal solution. Now you can see every row one allocation is there, every column one allocation is there, means we are done. So this is your answer. So now this is your output what you got. This is the final output what you get. Now this final output, if you compare to the original data, so if you compare this output to the original data, so if you compare this output to your original data, so your original data was 10, 3, 3, 10, 3, 3, 2, 8. This is your original data. Then 9, 7, 8, 2, 7. Then 7, 5, 6, 2, 4. Then 3, 5, 8, 2, 4, then 9, 10, 9, 6, 10. Now, if you see the allocation, if you see the allocation, the first is done on this. Okay. Then second one on this, third one on this, the fourth one on this, and the fifth one on this. So you have mechanics. Now you have mechanic A, you have mechanic B, your C, your D, your E, and these are your job. Your job were 1, 2, 3, 4, 1, 2, 3, 4, 5. So these were your job. Now these were your job. Now these were your job. Now you can see these were your job, and these were your mechanic. So mechanic A got the job 2, mechanic B got the job 4, mechanic C got the job 5, mechanic D got the job 1, mechanic E got the job 3. And I can find the total cost. So the total cost, which is your optimal cost. So your total cost would be 3 plus 2 plus 4 plus 3 plus 9. This is 9, 9 plus 9, 18, 21 rupees. This is your total cost. So this is your total cost. So, and then you can write the job allocation at the last. You can write the job allocation. You can, based on this, you can write job allocation, that you can write job and mechanic. You can write job and mechanic. Job 1, which mechanic got B. Job 2, which mechanic got A. Job 3, which mechanic got job 3 E. Job 4, which mechanic got job 4, which mechanic got mechanic B. Job 5, which mechanic got mechanic C. And your total cost is 21 rupees. So this is the work. This is the game what we play. So this is the game what we play. So we'll keep playing this game till the time we don't get optimal allocation. Your optimal allocation is that allocation where every row and every column you can see one element being allocated. Then only it is optimal allocation. In case if that is not done, then the allocation is not the optimal allocation. So what we had done in the assignment problem, So when we got the assignment problem, so what we had done in the assignment problem, so this was a problem. It comes for every year in your exam for 5 marks. So what we have to do in assignment problem, once we got the matrix, two things we have to make sure once we get the matrix. First thing, that it should be square matrix. For the assignment problem, the matrix should be square. Okay, if that is not square, make it square by adding dummy row or dummy column. Okay, the first thing, it should be square matrix. The next thing, we have to make sure that the objective function should be minimization. Once that part is done, now what you will do, now the first step will be, you have to identify the smallest element in every row. You have to identify the smallest element in every row. You have to identify the smallest element in every row, and you have to subtract all the element of the row from the smallest element. Okay. Then you have to identify the smallest element in every column, and you have to subtract all the element of the column from the smallest element. So you have to do this work row wise and column wise. So you have to identify the smallest element in every row, subtract all the element of the row from the smallest element. You have to identify the smallest element in every column, subtract all the element of the column from the smallest element. Ultimately, then you will get a data which consists of a matrix where some zeros will be there in row wise and column wise. Then we'll start doing allocation. So once you start doing allocation, you will give preference to that row which has 1 0. So do the allocation to those rows which has 1 0. Once you done row wise, then do column wise. See column wise, see those columns which has 1 0 and do allocation. Then you will see those row wise to those rows which has 2 zeros, one cancelled, one allocated, one cancelled, one free, which to be allocated. So you'll see column wise, you'll see columns to those rows. First you see row wise to those rows which has 2 zeros, one allocated, one cancelled. Then you'll see column wise which has 2 zeros, one cancelled, one available. So then see row wise, then see column wise, then keep observing like this, row wise and column wise. Once you're done with this, like that you have to follow. First 1 0, then 2 zeros, one cancelled, one available, then maybe 2 zeros, both available, then maybe 3 zeros, one cancelled, two available. Like that, one by one you have to do. So one by one you have to do in such a way till there is no zero which can be allocated. Once that part is done, then you have to see, is every row uh, or every column is allocated. If that is not done, it means it's not the optimal allocation. Now if you see here, the row 5 is not allocated. Row 5 is not allocated. Row 1, row 2, row 3, row 4, the 4 A, B, C, D, all the 4 rows A, B, C, D is allocated, but row 5 is not allocated. So in order to do the allocation, what you have to do, now we'll follow some steps. We will follow some steps for the optimal allocation. For the optimal allocation, we follow some steps. So what are the steps? Now you for the optimal allocation, what are the steps? You tick that row which is not allocated. You tick that row which is not allocated. You can see I have ticked the row 5. So you tick that row which is not allocated. Now in that row, see where 0 is there. So 0 is here. So tick the corresponding column for that 0. Okay, I have done that. Now what you do, you see in this column. Now see in that column, see where allocation is there. Yes, allocation is there. So if allocation is there, then tick the corresponding row for that allocation. Okay, once you've done this, now what you have to do, you have to draw a line on those rows which are not ticked. Draw a line over those rows which are not ticked, and draw a line over that column which is ticked. So after that, you draw a line over those columns which are ticked. You have to draw lines over those rows which are not ticked. Once you're done with that, now you see those elements which are not ticked. Now you see those elements which are not, lines are passed over them. You see those elements where no lines are passed over them. Now three things will happen. Ultimately, when you see this, three things will be happen. Now if you observe this, three things will happen. What are those three things? either no line passed, either no line is passed over element, either no lines is being passed, or either one line is passed over them, or either two lines are passed over them. Any of the three things can happen. Now, if you see these elements, three things can happen. Either no line is passed over the element, or either one line is passed over the element, or either the two lines are passed over the element. Okay. So now what you have to do, you have to determine theta. Now once you understood this, now you have to determine the theta. Now you have to determine the theta. So what is theta? Theta is the smallest element. Theta is your smallest element. Theta is the smallest element over which no line is passed. Over which no line is passed. So that is your theta. So theta is your smallest element over which no line is passed. That is called as theta. So the over which no line is passed, that value is called a theta. Now what you have to do with the theta? Now what you have to do with the theta? So all the elements where no lines is passed, subtract that element from the theta. From all the elements where no line is passed, subtract that element from the theta, because theta is the smallest of all these elements. So subtract these elements from the theta. And if one line is passed, then do not change those elements. If one line is passed over any element, do not change that element. If two lines is passed over that element, then add theta to those elements. Okay. So you have to do this work. So with that, you'll change the values of every rows and column. So once you've done that work, now the value what you got, once you've done that work, now the values what you get, again you'll have few zeros in row wise and column wise. Again you'll do allocation. When you do allocation, you'll give preference to that row where 1 0 is there. Then you'll give preference to that column where 1 0 is there. Then you'll give preference to that row which has two zeros are there, one cancelled, one available. Then you'll give preference to that column where two zeros is there, one available, one cancelled. Like this, we follow this game till there's no zero which cannot be allocated. If you feel that all rows is being occupied, allocated means it is optimal solution. If that doesn't happen, then again you have to continue the same game. You have to take that row which is not allocated. In that row, see where zeros is there, to tick the corresponding column for that zero. Now inside that column, tick that row where allocation is there. Now draw line over unticked row and ticked column. Now identify the smallest element from all the elements which are not crossed. That element is called theta. Then subtract all the elements which are not crossed from the theta. Do not touch the element which is crossed once. Add theta to all the element which is crossed. Again you will get a new matrix. Again you do allocation of the matrix. Again, if everything is allocated, every row got allocated, means you got the optimal solution. In case if that's not allocated, again you will follow that same story where you tick that row which is not allocated. In that row you go and tick where zero is there, tick the corresponding column for that. In the corresponding column, tick the row where allocation is there, then draw line over unticked row and ticked column, and then again determining theta, adding not touching or subtracting theta. Again the same process we keep doing till the time we find allocation in every row. So that is all about Hungarian approach. So this is called as Hungarian approach. This method of solving the problem where we are discussing a special case of assignment problem where every job is to be allocated to one person and one person cannot get more than one job. This way of doing allocation, this approach is called assignment problem. And in the assignment problem, these are the steps which I told you that you have to keep in your mind while solving the problem. Tomorrow we'll do more problem like this. Anyone have any doubt, please ask me before I wind up the class. So anyone have any doubt, please ask me before I wind up the class. So this was the problem what we are solving. So we had done one problem today. Tomorrow we'll try to do little bit fast, because tomorrow I will not write this theory and all. This theory what I told you, this I did for today, because today is the first class. So I have to tell you the theory of the steps what we need to work on. You can watch the video. The video you will get very soon in the group. You can watch this video, practice the question like this. Also, you can see previous year question paper of Bangalore City, and you can start solving the question based on that. And if you have any doubt, please feel free to ask tomorrow. Okay, okay, guys. So I think everyone has understood whatever I have done. So thank you, everyone. God bless you. Bye.